Hello everyone and welcome to another tutorial video. So in this video we'll be treating Cartesian vectors. Okay, so in previous videos we talked about how to find resultant forces and all that. Okay, so in case you've not watched that video, kindly go check that out before you come to this video. Okay, before you proceed with this video, I'll just link a card to the top of this video, or you just check our playlist and then you find the video over there. Okay, under basic mechanics. Okay, right. So without further matter ado, I would urge you to subscribe to the channel, turn on your post notifications so that you don't miss out on any uploaded video or future videos. And in case you are an old subscriber, thank you for subscribing. And then let's proceed to this video. Okay, so in this video we'll be looking at what Cartesian vectors and then how to solve questions on what Cartesian vectors. Sometimes you may be given forces in polar form. Okay, forces and their angles in polar form. You could be told to what convert them to Cartesian vectors. Okay, it's all about vectors. So Cartesian is all about the notation, that's ijk. Okay, and then we have what them being what vectors. Now note that this is not a full course tutorial video. Okay, this is just about pinpointing the most important key points you need to know. Okay, these are what the most important things you need to know. There's no need to go try to the entire course. Okay, these are the most important things you need to know. Once you know these formulas and then you know these concepts, you are good to go. Okay, right, so let's look at the first concept or formula you need to know. Okay, so Cartesian vector representation. So this is how we represent Cartesian vectors. Okay, as I already indicated, they are what ijk, and then they are supposed to be vectors. So axi plus ayj plus azk. Okay, it's just as simple as that. Now we already know how to find magnitude of forces, so that's the same approach we'll be using to find what the magnitude of what a Cartesian what vector. Okay, it's the same approach. You just take the square root of the entire what forces. Okay, then you raise their respective powers to 2. Okay, just like here. Now, so once you know the magnitude, you have to also know the direction. Okay, right. So now once you know the direction, you can know the magnitude of the force. Okay, so this means that once you know the magnitude and you know the direction, you can know the angle. Okay, it's as simple as that. So this is what for x coordinate. Okay, or for the x, and then this is for what y. Okay, and then this will be for what k or z. Okay, right. So this is how you find what the direction of a Cartesian vector. Okay, cos alpha equals what cos alpha equals what ax, that's the x direction, divided by what the magnitude. Note that this is what the magnitude. Okay, and this is the respective forces along the x, y, and z. So this is how we represent what the Cartesian vectors for 3 directions. Okay, right. So we have the x positive. Note that in this direction is what the positive. Okay, and this direction is the positive for the y, and this direction was positive for what the z or k direction. Okay, note this is very important. Okay, very important. Sometimes you might calculate for an angle, and then per the value you get, you have to decide whether you use a specific value or the other, because the direction, okay, either positive or negative will the direction of the force, either positive or negative, will let you know whether to use a specific angle or not. Okay, you might solve a similar question, so just stay tuned. Okay, right. So as always, this is how you find what the unit vector for a Cartesian vector. Okay, it's the same as what finding the unit force for any Cartesian force. Okay, so you just divide the main force by what the magnitude, just like here. Okay, it's just as simple as that. Now this formula is very important. Okay, you usually use this formula once you are given only 2 what angles. Okay, so you could be given alpha, beta, and then you are told to find what gamma. Okay, or you could be given beta, gamma, and told to find what alpha, or vice versa. Okay, so this formula is very important. Keep this in mind. You will be using it to find missing angles. Okay, missing angles. Okay, right, because the angles might be 3, but you would be only given 2. then you have to use this formula to get the third angle. Now, sometimes you might have to convert the polar forces to Cartesian vectors, okay? So in converting polar forces to Cartesian vectors, this is the formula you'll be using, okay? This is the formula you'll be implementing. You just have to multiply the specific force by the angle with cos times the angle, okay? The specific force, then multiply that by cos times the angle. After that, you end up with this simplified Cartesian vector expression, okay? Now, sometimes you might need to add Cartesian forces, okay? So for Cartesian forces, just like adding summation of forces, you just sum them according to their coordinates. That's x, y, z, okay? So that's where we also implement this formula, okay? So once we know all these formulas, you'll be just implementing them in solving questions, okay? It's just simple. Once you know these formulas, you are good to go, okay? You are good to go. Once you know these formulas, you are good to go. Now, let's take an example and then we see how we solve that example. Now, so we have to express the force F. So this is the force F, okay? This is the force F. We have to express it in Cartesian vector. Now, so initially I indicated that sometimes you need to convert certain forces into Cartesian coordinates, okay, by using this formula, okay? So this is the formula you'll be implementing. You'll be just using converting the polar force into Cartesian vector, okay, right? So from here you can notice that we are given two angles, okay? You are not given alpha, but you are given beta and gamma, okay? This is beta and then this is gamma. So we'll be also using this formula, okay? We're also using this formula, right? So let's see how we solve that. Let's look at the solution, okay? So first we have to find alpha, okay? We have to find alpha. So that's where we use cos squared alpha, okay, plus or squared beta plus cos squared gamma to be equal to 1, okay? So we just have to do the substitution and then find alpha, okay? So we have something like cos squared alpha plus cos beta, which is 60, okay? 60 squared plus cos gamma, which is 45 squared to be equal to 1. So now let's try find alpha, okay? So in order to find alpha, all you have to do is just use this, okay? You just make alpha the subject, okay? So you just end up with the whole of this. So we have 1 minus cos 60 squared, okay? Then we have plus cos 45 degrees squared, okay? So after this, all you have to do is just find the final answer. Now note that the final answer is plus or negative, okay? Plus or negative because of this root sign, okay? So we have cos alpha will give us when you compute the whole of this, you end up with 0.5, okay? So when you pick up your calculator and then you compute the whole of this, that's 1 minus cos 60 squared plus cos 45 squared, you end up with 0.5. Now, in order to know whether to use the positive value or negative value, so let's first find our alpha, okay? So alpha is equal to cos inverse of positive or negative 0.5, okay, which will give us when you compute this, let's see, cos 0.5, okay, so that is positive 60 degrees or negative 120 degrees, okay? So it could be positive 60 degrees or negative 120 degrees, okay, or positive. So let's put it in this way, okay? Let's put it in this way. Okay? So we have we have 60 degrees and then 120 degrees. Now, so in order to know whether to use 60 degrees or 120 degrees, you have to know one thing, okay? You have to know the direction of the force, okay? You have to know the direction of the force. So by inspection, okay? So from inspection, we could notice that the force is in the positive direction, okay? The force is acting in the positive direction. So in case the arrow pointed downwards, it means that the force would have been acting in the opposite direction, okay? So from here you can notice that y is in the positive direction, z is in the positive direction, so the force is in the positive direction. So in simplicity, we will be using this angle, okay, because from here this is like calculating what cos what minus 0.5, okay, and then cos of what 0.5, okay, and then we ended up with these answers, okay. So in simplicity, our main angle, that's alpha, will be equal to what 60 degrees, okay. But in case it was supposed to be, the force was supposed to be acting in the negative direction, you might have used what 120 degrees, okay. Now let's try convert the polar forces to what the Cartesian what coordinates, okay. So let's do that over here. Right, let's do that over here. So now we know our main force, okay, and then we know the respective angles, okay, 45, 60, and then 60, okay. So all we have to do is just convert the polar form into Cartesian vector, okay. So the forces will be the same. So we have the main force, which is a cos alpha xi plus the same force cos beta yj, okay, and then plus a cos gamma zk, okay. That's what this means. So let's see how we solve that. So we have fr, okay, and then we have 200. So we have 200 cos of alpha. So alpha is 60, okay. Alpha is 60 I, okay, plus 200 cos of beta. Beta is also 60, okay, j, okay, and then plus 200, okay, plus 200 cos of gamma. Gamma is 45, okay. So 45. Okay, so now all we have to do is just compute this. All we have to do is just punch this on our calculator. Now once you punch this on your calculator, 200 cos 60 will give us 100, okay, 100i. 200 cos 60, the same thing, will give us 100i, and then 200 cos 45, okay. 200 cos 45 will give us let's see, okay, so 200 cos 45 will give us 141, okay, 0.4k, okay, 141.4k. So from here you could notice that we've been able to convert the forces which were in polar into Cartesian vector, okay. This is what this is all about, okay. So from here you could just calculate the magnitude, okay. You could just try calculate the magnitude, because this is the resultant force, okay. So calculating the magnitude for the main force, we have 100 squared plus 100 squared, okay, and then we have plus 141.4 squared, okay. So when you punch this on your calculator, you end up with the main magnitude of the force being you have 100 squared, 141.4 squared. So this will give us when you compute this, you end up with 200 newtons, okay, resultant force, okay. This will be our resultant force, okay. This will be our resultant force. This will be our polar being converted to Cartesian, and then this will be our alpha angle, okay. Right, you could see that this was very simple and straightforward. First, we're just trying to convert the force into Cartesian. So we've first found the angle which was missing, that's alpha. That's where we implemented this formula, okay. We implemented this formula to find the angle, define angle, and then from checking or by inspection we got to know that the angle is supposed to be 60 degrees because the force was acting in the positive direction, okay, positive direction. After that, we just converted the polar form into Cartesian, because we've been able to find the angle alpha, okay, and then that gave us this resultant force. After that, finding the resultant force, we could just find the magnitude of the resultant force, which was which we ended up with 200 newtons. Again, you could also find the direction, but it doesn't matter because we were first given the what, the angles. Okay, now let's try look at a second example. Okay, let's try look at a second example. Okay, so from here you can notice that we are told to determine the magnitude and what coordinate direction angles of the resultant forces acting on the body. Okay, so this is the body. Okay, so still we are implementing what, a Cartesian vector principles. Okay, so now we are told to what, determine the magnitude and coordinate direction. So we are finding what magnitude of these forces and then what, the direction of the forces. So finding the magnitude and then direction of the forces. So let's see how we go by that. Let's see the solution. Okay, let me just change this to white so that it will be clearer. Okay, now in finding the what, magnitude, okay, we have to sum these up. Okay, that's where we have what, summation of the forces. Okay, that's where we have summation of the forces over here. Okay, that's where we have summation of the forces. We have to sum everything up. Okay, sum everything up before we can find the magnitude. Okay, so we have what, summing everything up. Okay, summing everything up, we try to sum these forces up. Okay, so along the what, F1 and what, F2. Okay, summing F1 and F2. Okay, so we will be summing it along the X, Y, and Z. Okay, keep that in mind. We'll be summing it along the X, Y, okay, Y, and then what, Z. Okay, keep that in mind. Now let's do the simple addition. Okay, this is just simple addition. So we have what, we have 50i, okay, minus what, 100j. Note that we will be doing something like algebra. Okay, we'll be adding like terms. Okay, so we have what, 60j plus 80. Okay, I'm just rewriting this. Okay, but in the form of addition. Now let's see how we just sum them up. Now we add like terms. Okay, so this is 50i. We don't have any I over here, so we have what, 50i. Okay, and then we have what, minus 100, and then what, minus 100j plus 60 what, j, that is what, minus 40. Okay, minus 40j, and then we have what, 100k plus 80k, that's what, positive 180k. Right, so after finding this, we could just find the magnitude. Okay, it's just simple and then straightforward. Okay, so we have FR. Let's find the magnitude. So we have what, 50 squared. Okay, so let me rewrite this. Well, it doesn't look like a squared. Okay, so 50 squared, and then we have what, minus what, 40 squared plus what, 180 squared. Okay, so let's compute this. So when you compute this, okay, you end up with what, 191, okay, 0.0. Okay, so let's check the unit for the forces. Okay, it was in what, pounds. Okay, pound force. So let's leave that in pound force. Now this is what, the magnitude of the force. Now let's try to find what, the coordinate direction angles of the resultant forces. Okay, this is where things become tricky. Now since we have what, the resultant force, we need to find what, the unit vector, so that we will use the unit vector to find what, the directions. Okay, so for the unit vector, of the Cartesian vector, okay, the unit vector of the Cartesian vector. So from here, okay, unit vector of the Cartesian vector. So this is what we are using. Okay, we will be implementing. Okay, right. So we just have what, the force and then divide that by what, the respective force divided by what, the entire magnitude. Okay, so let's see. Okay, so we know the respective forces over here. You just divide it by what, the recently calculated magnitude. Okay, right. So we have what, the unit vector for this. So we have what, 50 on what, 191. Okay, that's I, and then minus what, 40 on what, 191, that's J, plus what, 180 on what? 191, which is k. Okay, so once you compute this, you end up at what? When you point 50 on 191, you end up at what? 0.2617 ki. Okay, minus when you punch 40 on 140 on what? 191, you end up at what? 0.209 j. Okay, so it could be 0.209 j, or let's add 4 j, and then plus what? 180 divided by what? 191 will give us what? 0.9422 k. Okay, so let me rewrite this. Okay, 0.9422 k. Okay, so we have what? 0.9422 k. So the question stated the coordinate direction angles of the resultant forces acting on the body. Now, so from these unit vectors, you could just find what? The respective angles. Okay, so you know that cos alpha is this. Okay, cos alpha is equal. Okay, so from here you could just find what? Since we know that cos I, so initially note that this, okay, these correspond to what? I. Cos beta corresponds to j, cos gamma corresponds to k. So that's the same principle we are using over here. So cos alpha corresponds to I, and then cos beta will be corresponding to j, and so on. So we could find alpha from here. Okay, so when you compute alpha, okay, when you punch this on your calculator, you end up with 74.8 degrees. Okay, let's look at cos beta. Okay, which is what? Minus 0.2094 j. So when you compute for beta, okay, so we have cos inverse of what? Minus 0.2094. So from here you can notice that we have what? When you compute this, cos inverse of minus 0.2094, you end up with what? 102 degrees. Okay, and then when you compute for what? Gamma, okay, which is 0.9422. Okay, so finding gamma, we have what? Cos inverse of what? 0.9422. Okay, so when you compute this, you end up with what? Gamma being what? 19.6 degrees. Right, so from here you can notice that only beta had a very high angle. That's because this was what? Negative. And then since beta is what? Negative, okay, the cos beta give us what? A negative value. You could notice that the beta angle, the angle of beta is greater than what? 90 degrees, since it was what? Negative. Okay, right, I hope you enjoyed this video. Okay, in case you did, and this video was very helpful to you, and I would urge you to subscribe to the channel, turn on your post notifications so that you don't miss out on future videos. And then thanks for being a subscriber to this channel, and then I will see you in the next video. Bye bye.